Alright, in the last video I showed you how to take some put image array and save it to disk and load it back in again. And that was good for images up to a certain size. Once we get up to 32K or higher, it becomes a problem. So that doesn't allow you to save the whole screen. But I've written some new code, and this allows you to save all the different QBasic screen modes and load them back in. Unfortunately, it's a bit slow with the high res modes, but I wanted to just write some plain code and write it in a short, compact way that it did it in a simple way. And this is what I've come up with. It's easy to modify. You could add your own features. There's no compression or anything, but just to be aware of, again, it's slow. So the code is simple to read and simple to use. I'll go through it right now. So we're in Visual Studio Code, but I'll switch to QBasic and I'll run. This is the exact same code. And let's just start with screen mode 1. And so I've drawn a border and some circles. So the first time around, it drew and it saved, and then you saw the flicker that loaded the image back in. So let's do it again, and it's not bad. So it's saving now, and the flicker, and it's loading now. So not bad. So we can switch to screen 2, and this is monochrome, 640 by 200, and I'm switching these screen modes in a few places. Here, when we specify saving, we have to tell it what screen mode we're saving, so that way you could define the right width and height for saving the file. And here we're just changing to a different screen mode. This could be anything, and switching back again, so that way it wipes out everything on the current screen. And so let's try this, and so you can see it's only taking up half the screen, but it is saving the whole screen. And again, not too bad. It saves and loads pretty quick. So now let's move on to something a little tougher. Let's do 320 by 216 colors. So that's screen mode 7, and this is where things start to slow down a bit. And there we go. So it took roughly 4 times as long. Anyway, but still not too bad. Let's go to screen 8 and see how that fares. So each time we're going up to higher resolution, and it just takes a little longer. So I believe this is 640 by 200. And this is where things start to really slow down. All right, so let's try screen 9. I think the screen 9 is 640 by 350. I'm not quite sure. Let's see what happens. That actually might be 640 by 480. Not quite sure. Anyway, it is taking a while. All right, now it's loading. And it's done. Okay, so it does take a while. So I'm just going to go over the code and explain what I've done here. Again, this is an enhancement to the previous code I showed you with the put image array. And if we look at the new functions here, so I have a get screen height and a get screen width. And if we specify the screen mode it returns back the proper height and proper width. So those are easy. Image buffer size, this returns the amount of memory we need to allocate for the um, array. And this is a slightly modified QB64 example that I've snatched off their site. I made a slight enhancement by putting in the option to put in the coordinates to figure out the image size. This is similar to what Borland provides with their own image size function. And here's where it gets interesting. So let me jump to the save screen file. So we're using a couple of variables to store the width and height, and then size to get the array size. We're only going to need one line for the image because we're doing one line at a time. Uh, this solves the problem of going beyond 32K or even 64K or whatever the size of the screen requires, because storing one line is way below, it's way below a couple of K even. So that's easy to allocate. We won't get any problems there. And we're dividing it by 2 because we're using an integer array. Image buffer size returns the byte size, not the integer, so we divide that by 2. And we're minusing 2 because we're not using the first two integers. And well, that's kind of conflicting with what I'm doing here. I'm adding an extra couple, but that solves a different problem. Anyway, I have a pad variable here, and this is if you do option base 1, this will still work with that. So if you don't, this remains 0 and really doesn't affect the code. If you notice here, I'm using a slightly older format, and this works with Amiga Basic as well, so I try to make things compatible across, even though it's completely different systems. So this works in Amiga Basic as well, and I use it. You can modify it if you want, change the open as binary instead of specifying open. R is for random access, it's not for read. And this is where we specify the field format, and this is how we actually we convert uh, integers into strings, and then it writes it as a record with the put command. This is different than the put command we use to display the image, so it can look a little confusing, but put with the number 1, it's writing data to disk. Put with coordinates and the array, that's putting images to screen. So if we look here, not this one, right here. So this is the put command that puts images on the screen, different than the put command that writes data to disk. So it's a little confusing if you're not versed with the QBasic. Anyway, so again, I'm looping right here. So we write all the data to the screen, the width and the height. We write that to disk. And then we have a for loop here that goes line by line. And we're grabbing each line and storing it in the image buffer. And then we're converting that format to a string format with 4 bytes and writing that to disk. So we're looping through the entire screen here and saving it to disk. The read screen file is the reverse. So we open the file, we get the screen mode, the width and height. We determine the size for the line we're going to need, how big the image buffer size. And if you notice here, I'm doing some patching of the width. QBasic doesn't store in the image buffer uh, the proper width for certain screen modes. For screen mode 1, uh, you need to double the width. I don't know the reason for this, but this is how it stores it in its array when you're using the get command. Uh, and the same thing with screen mode 13. It multiplies that value by 8. So we have to do the same thing here. So that's why we have these two lines. And again, we do a for loop where we cycle through all the data. So we read each line here. So the for I to size, that reads everything into this buffer, and then we display that each line with the put command, the put image command. And same as the way we were writing it, we just read it in reverse. So that's how this works. And what I hope to do in the future, and I think this is possible because I'm reading and writing the data in short bursts instead of reading the whole line data at once and writing it at once. So I think if I modify my code, I could make this actually useful. But for now, this is all I got. If you find a way to make this better or you have a better version of this, now I know there's, be save and be load options, but um, those those do work and they have their own specific needs, but I just wanted to write some simple code that's more general. And if I can improve this, I think it'll be a lot more useful to a lot more people. So if you have any comments, leave them below and I will answer them.